Nice. It's a chilly night. I was just looking at our temperature up here, and it's 26 degrees. So not an ideal night, certainly, but yet at the same time, it's a night that we're we're happy to be here. We've just turned the telescope to the position where this comet is supposed to be, and sure enough, it was right there in the middle of the screen, and it's bright even for the snapshots. We didn't have to even stack images of it. So happy to welcome you all here. We've already got some folks on the stream. If you want to just identify yourselves, maybe where you're from, where you're observing from, and let's get going. Let's see, why don't we start by just jumping right in here at the screen. Let's see. I wonder if this is what they talked about. I upgraded the OBS software that we use, and it said you'd have to re-initialize your display. So let me think of what that would be like. Let's try this. Yeah, there we go. Well, I'm glad that didn't take very long, because it certainly would have been no fun. So here we are. Let's get a little bit more width to this, so we can see a little more what's going on. In fact, I think I'll just pull that all the way down there, something like that. And so right here in the middle is the comet. Now, the moon's bright tonight. I don't know if we can get the exact percentage of the moon, 94%. So that's almost a completely dominant moon. Now, for some reason, our sky cam that we usually use to show you the sky and to stay connected with the sky, it is MIA for some reason. It's just completely black, and I couldn't get the camera to initialize, so I don't know if it's on strike because it's too, maybe because it's too cold out there or what, but it would not come back up. Let me get this power box up again, and let me try one more thing here. Cannot discover a known device. Well, that's a bummer. So that means the pocket power box is plugged. Oh, that's not good, because that's what does our do control. So that's not good if we've lost our pocket power box. That might mean that the cable is bad. Let me show you what I mean. Here's this pocket power box. It sits up on top of the scope on a little equipment plate. And maybe if that pocket power box has lost connection, that explains why we weren't getting power from this front little 183 ZWO 183 mono camera that we usually use to see the sky. If this pocket power box is no good, then we aren't seeing through the sky cam, and our dew control is off. So our scope might cover up with dew in a minute. Wow, that would not be good, would it? We'll have to maybe go out and work with that if that's what happens. So for right now, let's work with what we've got and see what happens. So back to the screen, and we'll at least go with the got. Looks like CK is on from Orlando, and Kim, welcome from Adelaide. Papa Tech from Central Florida. I bet the temperature is warmer down there. Ricky is there from Fort Lauderdale. And Sarah, welcome from the Pennsylvania-Delaware state line. Way too cloudy there. Yeah, we had clouds all the way up until right when we were ready to go tonight. So I know how you feel, Sarah, but welcome. Looks like we got 13 on. If you haven't told us where you're from, we'd love to have you do that. Okay, so you're looking right in the middle at the comet. Let's zoom in a little bit. Maybe a little more. And now let's start working on the exposure here. Let's go with, let's try to live stack for a while and see what happens. So we're going to set our, let me put the name of it in here. It's C 2022 E3 ZTF. Okay, now let's start live stacking this. Let's see. That's going to want to do another. I think I'll just start the live stacking manually. So let's try going with 20-second exposures, and let's reduce our gain down to about 100. And now let's start live stacking. Now, this live stacking process, you guys who have observed before, you know what we're talking about here. It's basically a process of combining or averaging the exposures that you capture, 20 seconds each. And then with those exposures, what you do is you maybe average out the background noise, and then you are able to combine the light sources, so you get a lot better image than what you would normally. So as you can see, we're kind of pumping up the mids here a little bit, and what we're trying to define is what's going to be the background. Now, with the moon just about what, maybe 30 degrees from this, while that's accumulating some frames, let's go over to Stellarium. And let's see what we're looking at. The moon is right here. And, you know, I learned the other night how to do this angular deal. Let me see if I can remember again how to do this. What was it? You know, I think it's, oh, here it is. Okay, so you click on that little download that plugin. And it looks like the angle is, let's see, 38 degrees away from the comet is where the moon is. So that's actually pretty close in astronomical terms when it's a 94% moon. To get oriented here, here's the Little Dipper. So if you were to look up in the sky and find the Little Dipper, here's the North Star, Polaris, North Celestial Pole. And if you just continued this curve on up now, kind of let the Dipper be a pointer, that's exactly where the comet is. And maybe a good way, here's the bright star Capella. So when you go from the North Pole over to Capella, you can remember it's about a little more than halfway across. And if you have binoculars, then you could definitely see this. I guess pointer star wise, it's kind of in the middle of a pentagon right now. Of course, it moves pretty fast, pretty quickly each night. Okay, let's go back over to our live screen and see how this is working out for us. Let's pull our definition of black down a little bit. And then let's pump up our mids. Now you can see the comet is already moving a little bit, even in this short amount of time. This is 3 minutes that we've been live stacking, and yet we can already see some movement there of the comet. That's how far it's moved in just 3 minutes. So really incredibly fast for an object up in the sky that, you know, we're used to seeing these pinpoints of light. This thing is booking it now. I believe the closest approach to the Earth was yesterday. So the closer the vantage point to us, the faster the apparent motion is going to look like. And now it's just looking like a little miniature line across there. Now this is interesting here in front of it. Now what is this shape? I can't tell you what that is. Some kind of an artifact in front of it of some kind? But with the moonlight, 94%, we're not getting a long tail anymore, are we? So why don't we stop live stacking and let's go to about a, maybe make it 10-second exposure with 300 gain, and let's take off our, let's take off our, maybe take off our darks, you think? Wonder what it would be like if we just remove the darks. Actually, let's start by removing the flats. See what that does to our image. I didn't see that much difference, did you? Not a lot of difference. Let's go to a 20-second exposure, but do it like real time. Okay, so it's down here on the bottom of the screen. Let me move this up a little in hopes that you can see that bar graph a little better there. Now you can see that bar graph at the bottom. Every time that reaches across, it's a new frame. Boy, we're just not getting a live tail, are we? Let's see, Kim's got no clouds and the moon is bright in San Diego. Susan, checking in from Arizona. The moon is bright there, I bet. We have about 22, so this is really good, actually. 22 on live stream. Let us know where you're from if you haven't already done that, please. I have to actually 24 now, so happy to have you. Let's see if we can figure out what this double star is here. Let's go back over to our planetarium software and zoom in. Here's the double star. That is not a named star. How about this one next to it? No, that just tells you how random these are. It just says star, and it's not even telling us that it's a named star. Those are like magnitude 11, and Stellarium doesn't have them named here. Let's go in our information pane. See, would that be under configuration window? Is that where that is? Information. Yeah, we're supposed to have names if there is one. So that's odd, isn't it? That we don't have a name for that star. That's how random. Now you see, like by contrast, a star like let's find a bright one here. All these are pretty dim though. Let's back off and go to like here. So that's 21 Camelopardalis, and it's Hipparchus 26700 or HD 371. So these stars should all have names. That shows you that this is not a particularly bright set of stars here, and probably tells you. I'm going to set this on now. Put this on now. Look how the RASA is not quite on it because it's moving away. This is where the RASA had it pinpointed when we started the broadcast just 16 minutes ago, and this is how far it's moved in 16 minutes in comparison to the sky. Simon says the sun is even brighter here in Perth. Papa Tech, do you have any filters on the scope? Just that normal one, the Celestron light pollution filter. If we didn't have the light pollution filter on, oh my goodness, it would be horrible, Papa Tech. This is a very, you know, the whole sky is light polluted with the edge of Louisville here. Let's go to a gain of 200 and see what happens. These are 20-second exposures. Let's go with back to a 15-second exposure. See if we can zoom in now and catch a little more of the tail. That's, my goodness, that's 100% right there. And there's a 15-second exposure. So not much tail in the moonlight, huh? Let's pump this up to 300 again. The gain. lot of tail, but a lot of what would you call that? Just you know, nebulosity around it, kind of. This is at 165%. Let's try for 10-second exposures and bring the gain up to 400. See what that does. Yeah, the moon is crazy bright. I wish we had a moon filter, but I don't think they make those. You know, you're filtering out, oh my goodness, there's your 400 gain. You can sure see that it is a greenish tint, for sure. Back down to here, and let's live stack again and clear out. I'm going to clear the live stack and start over again and see how it can do here. There's quite a lot of gain, huh? Part of that gain is because we started at 300. Let's clear that one more time. A lot of background noise just from the moon and the light pollution. So the comet reaches its closest proximity to the Earth yesterday. So in terms of size, it is the biggest now, but I don't know that really, you know, I don't know that we'll ever be able to detect it as more than a pinpoint because it's still so far away. Let's go out here and Comet C 2022. Some of you might wonder where the name comes from. The ZTF, it was spotted by the Zwicky transient facility back in March. That's a giant camera out on Mount Palomar that keeps scanning the sky for comets and other things that move. And then the E3 stands for the fact that the 3 stands for March, and the E, I think it was maybe the 5th, or the part of the month, that's what it is. The part of the month, I think, in which it was spotted. Let's see, let's go to the, look, this is, that's Neowise. I wonder, why does that look so good? That was Neowise. Let's go to this NASA image of it. That's nice, isn't it? This was captured by boy, that's a beautiful image. I wonder how long that is, how long an exposure. Anyway, it's discovered by the Zwicky Transient Facility, a wide field survey telescope. It's a very long period. I'm sure you guys have heard that by now, 50,000 years. And the tail, if it's captured well, is a couple of degrees wide. And like we said, it was at its closest to us February 1st, yesterday. It's kind of unpredictable how bright it would be, but that is so nice right there. And look, you can definitely see the greenish tint of the core, the coma around the core. I wonder if this, look at this little artifact here, if that could be part of what we were seeing in our live view. See how there's a little artifact here, isn't there? That's odd. Wonder what that is. Anybody got any theory? Andy, good to have you here. 33 degrees Fahrenheit in Clarksville, Arkansas. Moon here is trying to peek out through the clouds. Good to have you aboard it. Let's see, we've got 30 on board. This is a live view. We're looking at this artifact in front. Look how far I'm going to just zoom in maybe at 200% so you can see how far it traveled compared to the stars. And this is just after 3 minutes. That's how fast this thing is traveling. Let's go back out to the web and try to get its apparent velocity. Let's see. What if we said Green Comet velocity? Miles per gallon. I put in there miles per hour. 128,000 miles per hour. 26 million miles away yesterday. So however far it traveled in one day, it's a little bit farther now than 26 million miles. But it's traveling at 128,000 miles an hour. And again, by comparison, you know, a jet goes, what, 550 miles per hour. So incredibly fast. And you're seeing that now in this live view. What we're doing here is taking a picture every 20 seconds. We've captured another exposure. And then we record that. And then we take another 20-second exposure. And with the moonlight tonight, we're not picking up very much of this tail. I don't think we can pick up more tail, can we, if we bring these mids up? Actually, we are starting to see more of its tail this way, aren't we? I'm going to bring the darks down and bring the mids up and see if it helps us. The tail for us ends up being more of a pattern of just brighter light behind it there. See how dark this part of the sky is, and up here it almost looks like there's an extension, doesn't it? A little extension out this direction. Let's let that cook for a minute. It's only been there 5 minutes, and for a tail that's as faint as that tail, you would typically try to image that for 30 minutes. It's hard telling. The image we saw a while ago from the astrophotographer, that would have maybe been a couple of hours, and trying to track on the object. That would have been the way you'd capture that. Kim, I believe 2023 E3 means the third comet discovered in the first half of March. Okay, so the A, B, C, D, E. So you're saying the E refers to the first half of March, and then E3 would be the third comet in the first half. That's good. The movement of the comet, keep in mind you're guiding on the stars, so that artifact will be the comet moving between frames. But the artifact is different, isn't it? Because it's a hollowed out looking thing. So you're saying that dropout occurs because it moved away, and the part that stayed as the rim, are you saying that was just brighter or something, and so we preserve that part? Because there's a definite dropout of something there, isn't there? Yet the outer shell of it was preserved in these live stacked images. It's unique. Yes, live stacking. Right, we knew that this was the movement of the comet here, but it seems odd to me that there's a rim around the comet that continues to mark its outer shell. It just seemed odd to me. Now we could try to, we could use SharpCap's. SharpCap has a tool that lets you guide on a particular object. But I don't know, I tried that last time we did the comet, and I didn't really think it worked that well to try to center on the mass of the comet and use that as our guiding instead of the normal movement of sidereal motion, So basically what that does is makes corrections based on the central mass. Look how fast that's moving. That's what it looks like to go up 128,000 miles per hour. Now I heard a newscast today, and they had a lady that was like the the person that was giving the story, and you know how they'll have the anchor person interview the lady that's kind of coming on as the guest. And the lady that came on as a guest, bless her heart, I won't even tell you what station it was because I don't want it to seem like I'm disrespecting her, but she said, "I'm so sorry I didn't get up and see the comet last night." You know, like as if she was saying, "I missed it." And in the picture that they showed, which is some kind of animation, they showed stars streaming by behind it. So it must have been somebody's like animation of what it would be like if you were viewing the comet from just a few thousand miles away or something, because these stars were streaming by kind of like it looks like when you're at warp speed in the Enterprise on Star Trek. And you can see the stars, you know, moving by. And you can understand why the lady said, "Rats, I missed it when it streamed past Earth." But even though it's traveling quickly, the apparent motion in the sky is not as quick as that newscaster was letting on, because the last time, which has been what, a week ago or 10 days ago, I think it was like right here, and it's traveled this much of the sky from here just off the pole star over to here in 10 days, or however long it was since I did the last live stream. So 7 days. The last clear night we had, to be honest. So in 7 days, it's traveled that far. That newscaster lady didn't have to feel bad. She just needed to go out with a good pair of binoculars or a telescope like this. This is 11-inch RASA, Rowe-Ackermann Schmidt Astrograph. And we've got one of those ZWO ASI2600 Astrocams on the front, the business end of that RASA. And she didn't really have to, snap her fingers and say, "Rats." She could have just gone out with binoculars the very next night and tonight, and she could have seen it. But I think somehow she missed the point. Susan said, "Is the comet going to go into the sun?" No, I think, as a matter of fact, Susan, I think it's already looped around the sun and is actually now moving away from the sun and already heading back out. It's already made its loop. Yeah, I know. I noticed that a while ago. Simon is talking about how bright it is in the observatory. Let's see. Yeah, look there. It is bright enough. As he says, it looks like we have a light on, but we don't. This is the moonlight. And yet that's how bright it is. There is a little LED that's, it's the smallest LED you've ever seen in your life. It's just like a faint wheat lamp of a light that's up there on that garage door motor that swings the roof on and off. You know how we've got this is a roll-off roof observatory. That's not a live view image that you're seeing now. That's a captured image. I'm standing on a ladder and the sun's just gone down, so you've got some twilight in the background, just so I can give you a perspective of what the observatory looks like with the roof rolled off. And that wheat lamp that you see in this picture back here on the wall is so dim, it's so faint. But all of this light on the scope, that is the moon. And that's how bright. The moonlight is glinting off of that wall beam over there. That's how bright the moon is. So I'm seeing here that Kim is guessing that loopy structure may be an internal reflection being progressively stretched out via the live stack. Certainly strange. I don't think it's a reflection of anything that I have. I've even got this camera now, since installing the camera, I've even covered it in black so that there wouldn't be any reflections. So I don't think there's any reflection on the part of our equipment. But certainly what this tells me is that maybe the comet has a bright shape around the outside, and what it could be is that maybe as it moves away, it's clearing away the core, but the bright reflection of the comet on its outer shell isn't moving with the comet, you see. In other words, there's like a, the comet itself is like this rockish kind of ball of ice. It's kind of like a bunch of loose rocks that have been drawn together by gravity, and a bunch of frozen ice that's frozen this thing into big snowballs, so to speak. And as that snowball is moving through the night sky, then I bet what you have is the sublimation of all these chemicals, the chemistry that's inside of the ball, and the carbon dioxide and everything that's boiling off and being lit up like ionized by the sun, and that stuff doesn't move. It's the core that's moving. Now that's my theory, and I'm going to stick with it. 20-second exposures. We've imaged now for 14 minutes. So let's back off a bit now, and let's play with some of our settings here to see. Let's make the night sky darker to get rid of some of the moonlight. And then let's pump up the mids a little bit. You know, I would say that what we're seeing tonight in this 94% moonlight is more of a generalized glow around this object, a generalized green glow. No wonder they call it the Green Comet, right? Andy says, can the web pick it up, or can they control it to view it? I almost think this is in the wrong place for the web. The web always looks out into the darkness of space with its back to the sun. Whereas this object, if you can imagine it, it's streaming now at 128,000 miles an hour. It's streaming past the Earth. So I don't think that the web would be aimed in an ideal position to see this. I think the web, the ZTW telescope, could aim at the place where this came from, out in the Oort cloud. But it's not positioned so that it could aim at the comet, Andy. But that's a good question. The other thing is, this is moving so quickly. The web has such a tiny, I mean, it's like looking through this sky. If we had the view of the web here, it's like looking through a soda straw compared to what we're seeing here. I think the actual width of our frame is, what is it, about or is it 2 degrees, I think? 2 degrees 10 minutes of arc extent and 1 degree of 27 minutes. So just a little over 2 degrees by 1.5 degrees. And I would say that the web would be like looking through a soda straw of this. Once again, this view shows you our field of view of the RASA and just how far this comet has traveled in 16 minutes. So you can see the way it's just streaking. I mean, relatively speaking, it's streaking across the sky. Simon says you can definitely see the green tinge, though. And Simon says, I don't think that there's any point in live stacking on a comet, as the image will never be the same as a deep space object. I think you're right. I think we'll never be able to zoom in much, but I was hoping that we'd be able to pick up more of the faint glow. That's what I was kind of hoping. At this glow, and you see we can pick up a lot more of the green glow there, and we're getting that from the live stacking. This green glow around this comet wasn't apparent when we were just looking at raw 10-second images of it. But in the live stacking, we're exposing for the glow around it, rather than exposing for the comet itself. Now I'll kind of turn up. You can see when I turn up the whole sky because of the moonlight. Once again, if you've just joined us, to give you an idea, the moon is right here. And it's extremely bright, so 94%. It's almost full. In fact, I think tomorrow night, let's see, I'll tell you, and we're going to be on tomorrow night, Lord willing. I think it's going to be a clear night again tomorrow night, so we'll come back. It's at 98% tomorrow night. And I think tomorrow night we'll go 9 to 11, 9 p.m. to 11 Eastern time tomorrow night. So I think the live stack does help us pick up more of the greenish glow. And it also helps us see the speed at which it's traveling. Because you can see that, you can see how every 20-second exposure, how far it's moved. Simon says he loves the sound effects. Is that the music in the background? Silver Girls, good to have you aboard. My son and I have been looking for hours binoculars here in Utah. Any tips on locating them? Yes, I am so glad, Silver Girls, that you are out there. If you can find the Little Dipper, now first what you might do, for those who are not used to looking for the Little Dipper, you could find the Big Dipper first. And then use the pointer stars on the end of the bowl here to find the North Celestial Pole. That'll get you started with understanding the handle and the little cup or bowl of the Little Dipper, or the Ursa Minor. Now follow this curve in the direction of Capella. It'll be the next bright star that you come to. So if you follow the curve of the Little Dipper handle, it would take you to Capella. About 70% of the way. So in other words, it's not just halfway. 70% of the way, there are two little stars right here. And they kind of form a crown or a circle. And just outside that crown or circle, there is a thing that's going to look like a trapezoid here. So if you can find in your binoculars this little crown or circle here, and then go like up and to the right as it happens. In fact, from the Little Dipper, this is Minkalinen star name. From the Little Dipper, if you can imagine pointing toward both of those stars that you'll be able to see there in Auriga, it would be about a little over halfway to Auriga, and right in the middle of a giant triangle that's formed by Polaris, Capella, and Minkalinen. It's not like there's not a particularly bright star next to it, but it's going to be among a fairly groups. Let us know, Silver Girls, if you find it. David, you're so kind to encourage. We're thankful that you are on here. David, we're looking at this Comet C 2022 E3 ZTF. And we pointed out that the E3, the E stands for the first half of March, the 3 for the third comet spotted in the first half of March, C stands for comet, I guess, and in 2022, just of course it refers to the year in which it was discovered, March of last year. So this is a fairly new sighting because it's traveling from so far out and so fast that we didn't even discover this until last March. You know, there are a lot of comets that are known to us, and this was not one of them. So again, the live view here, you can see how much it's moved and how green the glow is here for that, all that background, all that glow around it. This is 22 minutes now of live stacking. Let's now brighten up the sky. No, it looks better when you darken most of the sky and then keep the mids up, we're not seeing, I don't think we're seeing any kind of tail in this moonlight. But you can definitely see that all these other stars are traveling because the Earth is rotating, and so all those other stars are basically staying the same because they're so far away. They look like they're staying the same in relationship to the Earth rotating on its axis. But there is one thing here that's not staying the same. As you can see, it is sweeping across the night sky. Now, a while ago, in order to see this in a little truer way, we dropped off our flats. And I just hoped that that would let us see a little more of the true colors. And indeed, it is letting us pick up all of these true colors. But you can also see by dropping off the flats that I shoot, we're picking up a little bit of vignetting around that left outside of our APS-C formatted camera. And these flats that we shoot in astronomy, it has to do with measuring the vignetting or the falling off of the light image at the edges. We dropped those flats on purpose in hopes of picking up all of this glow so that it would be all exactly as we're seeing it for real in the night sky. You have a lot of light pollution out there in Utah. So are you in a city, Silver Girls? If you're in the city, you're right. You would need to see that tail, I think you would need to be out in the country. And then on a moonless night would be better. Then you could actually see a long tail, even with an 11-inch telescope. That's what some people would consider to be a fairly large scope for an amateur size scope. We are not making out the tail tonight, just in the moonlight, and there's some light pollution here as well. And maybe the tail is just, who knows, just becoming fainter and fainter. I'll tell you what, let's shoot an image of this now, exactly as seen, so that we've got this thing recorded exactly like we have it. And then let's stop the live stacking and go back to seeing the comet like just one shot at a time. So we're going to stop the live stacking now. And let's go back to maybe, I don't know, what worked best. What do you guys think? Was it 15 seconds? Is that what worked best? And maybe 200 gain. See what that does. Now this is just now a snapshot. So in other words, imagine just taking a 35mm camera or a DSLR and just taking a snapshot of the night sky. And that's what this is, just a snapshot. So at 200%, you can still see a little bit of the glow around it, but you certainly don't see that accumulation that the live stack was giving us. Let's amp this up to about 300%. And let's reset our display histogram here. I wonder if we try auto stretching. No, I didn't think that would work. I don't think we can do much with this, but we can try with it live. Is there a color? No. What I'm doing now is I'm tuning the display histogram in hopes of, there's no way to adjust the color over there in that display histogram, is there, guys? I took some pictures last night, but my focus is bad in the cold weather. It's a bit of a problem for me. -7 Fahrenheit and it's snowing. Wow, that is cold, I'm telling you. All right, so what we've done now is we've brought up the darks to right about there. And now let's bring those mids. So what I'm messing with is the display histogram, and I don't normally tune the display histogram because we're normally live stacking, aren't we, guys? That's the third bar, which is kind of like the lighter whites, you know. But I wonder if we use that tonight, if we could tune out some of the moonlight. Now that is interesting. Notice how we can actually tune to see the core as being brighter. And then we can see that outer area, and this, guys, that's what was showing up in the live stack. And what that is kind of an aura, a green aura around the comet. All of that chemistry inside the comet that's being lit up by the ultraviolet light of the sun and ionized. And what we're doing here now is we're darkening the night sky a little more. Can you guys see that that green shell? It reminds me of the way a planetary nebula looks. You've got, you know, in a planetary nebula, you've got the white dwarf on the inside, and that's like the snowball. And then you've got the green chemistry glowing around it. So when the comet would travel across the night sky and move in relation to our sidereal time with the scope tracking with the stars, the core would vanish in the next shot. So SharpCap would say, well, that core is no longer there, let's drop that out. But SharpCap didn't know as much what to do with all this greenish glow of all the chemistry around the core. Isn't that interesting? David said he was doing 15 seconds, no guiding, and the image is not bad, but he said, you have a big scope, and he just used a DSLR lens. Yeah, that would be nice, though, if the tail were showing up well, David. You know, that tail was like 1.5 degrees wide. I like this idea of seeing the inner core so bright and then seeing the chemistry on the outside. You can almost see a little bit of the chemistry being thrown out, sort of, from the core. So let's do a snapshot of this, just because that's interesting. But I don't know how in the world we can get that tail to show up. Let's bring it up to 400 for a second and just blow out everything. And let's reduce the sky. Bring our lights up. I wish we had a color balance here, but I don't think we do we? There is no color balance with this display histogram. So what I've done now is pull those lights way up and then bringing in more of the greens. Oh, I thought we might have seen a little bit of tail right there, just for a minute. sometimes it almost looks like in one exposure that we might have a little bit of tail running along this direction. But it's so tricky to get the histogram exactly correct so that that tail shows up, isn't it? That is a spectacular view of an object that is quite obviously not a pinpoint of star, though, isn't it? David's in New Brunswick, northeast. So the comet doesn't give much to see compared to the comet of Neowise. Andy, I was just wondering if this comet is picking up debris along its travels and has a potential to get bigger. You know, I think it burns off just as much as it picks up, Andy. I'm no comet expert. This is only my second comet to observe. But from what I've read, I don't think it gets substantially bigger because it's also losing mass because of the ice burning off. Every once in a while, I just think that I see a little bit of a tail for a brief moment. All right, let's go back to reset this. And let's set this under the green. And now let's drop our time down to maybe 10 seconds. And just see what we get with that. So keeping our gain kind of high, but now we're catching an exposure every 10 seconds. A little bit. Let's go with 7 seconds and keep our gain at 400. Just trying to get a more natural look. So much moonlight. Now we can darken the sky. You definitely can see something projecting out every once in a while. Not as much red light from this comet as there is green. So let's keep our baseline right there, and then let's bump the greens up. Now look at that. Look how we're seeing a little more tail now off in this direction. Let's keep on working with that. Boy, it's right there on the moonlight glow, but every once in a while you can see a little tail in this direction. If you've not told us where you're observing from, we'd love to hear where you're observing from. And then tell us if you've made any images of the comet or been able to see it live with binoculars. You can see it's close to these two ninth magnitude, what this might be as a double star perhaps, or maybe that's just a visual double. In other words, maybe these stars are, from our perspective, they might look like a double. And in reality, one's way out here and one's closer to us. So maybe they're not actually a real double. We call that an optical double. For it to be a binary star system, they have to be close and sort of revolving around the mass of their shared mass. And I don't know which those two are. I don't know if they're optical double or an actual binary star system. But for sure, it would help us locate C 2022 E3 ZTF if the Green Comet, it would help us locate the Green Comet if indeed you could find those two stars and use those as pointers. Once again, the part of the sky that we're observing here is just out from the handle of the Little Dipper on its way to the bright star Capella in the night sky. And so if you follow the handle of the Little Dipper and go toward Capella, then you're a little bit farther than halfway. That's the part of the night sky that we're studying tonight. Oh, I can do that every once in a while. I hold my, let's see, this is the now button, yeah. So now look how far this is the distance that the comet has traveled. This is the RASA, where it's pointing in the sky. So the comet is gradually traveling so far away from the center of our scope that eventually it would actually leave our field of view. Let's see, there's our full field of view, and it started right in the center. So it's traveled from here in the center all the way here in the short time we've been looking. So I don't know if playing with this there, now, is that my imagination, or can we see a little bit of tail there? I think that's it. I think we're seeing a little projecting out in this direction, even in a 98 or 94% moon tonight. These are real-time shots now at 7 seconds. 7 seconds per exposure. Look how much ice there is. You can see that this is definitely almost disk-like in its nature. This would compare, for example, if we were to look at the planet Uranus, maybe. In fact, let's do one more snapshot of this, and let's see if the planet Uranus is still up. Uranus. Let's see where we are in the night sky. It is still up, and do you guys mind if we go over to Uranus just to compare? So memorize what this looks like. Try to get that in your mind's eye. Okay. Now we can always come back to it if we want, but let's go to Uranus now. So what we're going to do is say slew to the current object, and we have the scope cam we can show you of the telescope slewing. We just don't have a good sky cam view tonight. The sky cam is just MIA. I don't know if it's a bad cable or what, but we lost our sky cam there. Now you see the RASA has aligned itself. So here's another view in our planetarium software. So see how the RASA has aligned itself, and what we're going to look for is we're going to see if we can see any of these moons. So that's the whole system, if we were to get that close of a view. But we're going to see if we can see, somebody write this down for us if you don't mind. Umbriel and Ariel should be out on one side. And then we should see Titania and then Oberon. Now I don't know if we'll lose Miranda or not, but somebody kind of write these down if you would please. Help us remember these. Umbriel and Ariel, and then Titania and Oberon. Umbriel, Ariel, Titania, and Oberon. Okay, so let's go back over to the live view. Let's do a, let's back off, and let's do a plate solve, which helps us make sure that the telescope is pointing at exactly the right part of the night sky. And So what it's doing is taking a picture of all those stars and comparing those stars to this software's internal database, and it was off a half a degree. So now it's going to move and put Uranus in the center, and that is Uranus right there. Now let's do what we did with the comet. Let's zoom in on Uranus, and let's go to maybe let's just live stack Uranus. How about that? So we're gonna go to oh, let me change my name here, Uranus, and let's, you know, it's going to do another plate solve, but let's let it. Wow, look at that. When it just took that quick snapshot, Uranus was the only thing that was visible right there in the center. And sure enough, that's correct. Almost FM says the humidity is so high. Where almost FM is, the humidity is so high, the sky is typically a Bortle 7 or 8. I can't pick it up even with binoculars, and when I know exactly where to look. Well, you know, tonight our little power Pegasus power box is not working. Must be a bad cable. We'll have to work on that before tomorrow night's live stream. And so we don't have a dew control going on out there, and we might actually fog up. So we'll see how that goes if we get foggy here later. So we're going to set our darks about right, our black level around right there, and then pump up the mid-level to about right there. And then let's zero in on this. So that's the planet Uranus, and our focus is not great. I guess the temperature has gotten colder, so these are a little bit ellipsoidal, aren't they? "80 seconds. I wonder if we should go to a focus real quick. You guys might be interested in this anyway. We have 46 on the live stack. You might be interested in how we do our focuses. Let's do that. So I'm going to stop the live stacking, and we have to disconnect from the camera. Close the camera. We open up another piece of software called Nina, and we use Nina because of its automated focus routine. In Nina we turn on the camera like that, and down in the lower right hand corner it says yes, success. Then we turn on the focuser. Now I've got the focuser on here in, no I don't, of course I don't. So we'll turn on the focuser. Do I? You know what, I think I still do. I know that the focuser won't work if we've got it turned on. So I'm going to disconnect the camera for a second, connect back to the camera here. That'll show me the panel, and I'm going to disconnect. Oh, no, we didn't have the focuser connected. Okay, let's try this again. We're going to disconnect the camera, and then here we're going to connect it in Nina. And then we're going to connect the focuser. So it did connect, okay. Go to imaging, and then we do this automated run. And this fascinates me. What it does is it takes two pictures, and it kind of averages the two pictures. And then it moves the focuser 20 or so steps in and takes two more pictures. And it sort of looks for an average between those pictures, you know. Then it moves the focuser like 20 steps more in, and then it takes 2 more pictures. Now by in, I mean it's moving the camera, let me see, it's actually moving the mirror. So it's moving the mirror away from the camera by 20 steps. And a step is like the breadth of a hair, you know. So these are like nano millimeters or whatever you want to call it. It takes, I think, with this particular focuser, I think it takes, if I remember right, is it 1,000 steps? Oh, I'm going to get this wrong, so you guys don't look down on me if I forget, but is it 1,000 steps in a millimeter? And so these are tiny increments. And what it tries to do is it tries to look at the luminance between the center and going halfway out to the edge of each star. And it'll typically pick up like around 200 stars. So it's metering off of a couple hundred stars, and it's trying to figure out whether or not the object that it was metering the luminance off of, if it got bigger. And as it travels, the luminance gets bigger. So look here along the left side of this graph. And think about what that means to the telescope. If an object is getting out of focus on a telescope, then it's becoming more like a donut shape. And if we, in fact, no, we can't go over because we had to turn off the camera for you to see this. But these pictures, if we could see them, they're a little bit more donut-like. And as they become donut-like, they're bigger because they're out of focus. And that makes the luminance bigger to the measurement of the telescope. So then, once it starts seeing, oh my goodness, you've got a big donut now, it goes back to the point where it started and starts going the other way. And it starts studying, once again, how far off is the donut in that direction. And you can see here on this curve, it's already way up to a big out-of-focus donut already. So very shortly, it's going to conclude, well, there's no sense in going any farther because your telescope is way out of focus now. And then it tries to come back to the middle. Now, I tell you, this one was way off. Now, that could have been a cloud. It could have just been a satellite that traveled across. So let's shoot one more time and try to get a little bit better bell curve. But what I've learned is when you start with the focus better, then the second focus is better yet. Because you see, you have a very small range that the RASA can see that's in focus. I did a study on this. With the RASA 11, the width of focus for that mirror moving in and out away from the camera is about the size of a human hair. That's how little the play can be. We're talking about like fantastically small amounts of movement here that mirror is moving in order to determine the right focus. So imagine if you're only talking about the width of a human hair. And if I remember right, the prime focus is actually smaller than the typical hair on a human. You can get down to like fine hair on maybe an aged elderly person that, you know, your Meemaw that's in the elderly care center. Her fine hair is what we're talking about here. And that's the area of prime focus for this telescope. It's so small that to me it almost seems impossible. Let's see, Goat Wave checking in from Colorado. You took your sister and nephew out with binoculars. That's great. Stu says hello from Tauranga, New Zealand. And Stu says, I'm sorry I'm late. Stu, don't worry about it. We just noticed that we were a little out of focus. Boy, we might be getting some cloud or some dew cover on the background there, huh? Kind of jumping around here some. But let's see what it comes up with. Almost FM. It's the downside of living in Central California. Winters are humid, summers are really dry, and when we've had a lot of rain, it just makes it impossible to see anything. Sorry about that. Simon, click on the imaging tab and you can see what you're explaining. Oh, you mean down here. Okay, let's see if we can see a live picture. I've never clicked here before. I wonder if we see, do we need to click on the image tab? Oh yeah, look, here's the image tab. So Simon, you've used Nina for more than autofocusing. I can tell. And here are our annotation options, star detection results, the aberration inspector. Nice, okay. So would you say that's the most recent image? Boy, I can already tell. I think I can see some moons of Uranus right there in that shot. Let's go back here. It's done now. Wow, that was a haywire thing. But now it shows here. I think we're going to have to do one more just to get this right, because we're about, now if we can be like a Goldilocks, you know, the first one the soup was too hot and the second one the soup was too cold. Yeah, Simon says that's the one, and Simon says I only use Nina. That's awesome. So in true astrophotography fashion, Simon only used Nina. So what we're going to see here now is each subsequent image is going to be a little bit less focused. So you can see now we've lost those moons of Uranus. Let me make this a little bigger. So something like that. We've lost most of the moons of Uranus now. They were there in the sharper image. Not the sharper image catalog from the vendor sharper image, but now we're getting kind of blurry. So let's see back where we are. Oh boy, that's weird, isn't it? Oh my goodness, what in the world is happening? You think this is cloud cover? Or maybe we've sunk below the trees? Where's the horizon here? It's kind of close to the horizon, but shouldn't be that close. Maybe it's the night glow of the city. Oh yeah, it's completely failing now. So let's see where it left things, and let's disconnect and let's look through the telescope again. That's the last image. Not ideal. Probably lost it in the glow of the horizon, because that is in the direction of the city of Louisville. Let's see if it does a little better this time. Yeah, Simon, on a good night when we're not aimed at the horizon, we get a beautiful bell curve here. Yeah, this is not going to be worth it. So let's look at the latest image. Not ideal. Okay, let's go here and let's go to something like Pleiades. Nope, there'd be too much nebulosity there, huh? Let's look at, where's the moon? Here's Mars. That might be too much. How about Aldebaran? Current object slew. So we'll go over to Aldebaran. So you can see the scope traveling there. This is actually and that's the real live image of the scope. And then here we are, and now let's try another autofocus now. So this autofocus routine is really helpful because it actually, because you're only talking about the width of a human hair, it actually is more effective than what I can do with my eyes. It's just a ton more reliable than what we can do with our eyes typically. That was looking bad there around Uranus though, because of all the, perhaps all the city light. Now we're doing better. Oh, Lionel Richie is in Joshua Tree. I would say you've got clear skies and probably dark skies too. Lionel, do you have a telescope set up there, or you're just out there living in Joshua Tree? I bet it's warm. We have about 32 people still on the stream, kind of getting our focus tuned up so we can look at Uranus and compare with how that looked compared to the Green Comet. Comet 2022 E3 ZTF. So now you can see this focus is looking a lot better right off the bat. It's already found a happy enough margin in one direction, and now it's headed back in the other direction, and it's going to be, I think, quickly very happy with this bell curve, and it's going to be able to find a sharp focus right there in the middle. So we'll look at our, oops, I spoke too soon. Look at that. So that's Aldebaran there. We'll see what it does with that artifact. Bummer. "29 palms in the middle of Joshua Tree." Well, that's a strange focus, isn't it? I wonder if these are occasional clouds that are going by, or maybe some, I guess, just atmospheric disturbance. So I told you this was more reliable than the visual focusing, but it's kind of tonight not really showing off the night that we choose to record the autofocus. And we'll get to autofocus here and look at Uranus and compare that to the look of the comet. So we'll go back to the comet here in a second, and it doesn't like fly out of sight. I was saying earlier, if you were on talking about a news lady who was saying, "Oh, I hate that I missed it." Well, it didn't like fly out of sight in one night. It's going to be around for some time. It was just that it was at its closest yesterday, but it's still visible and we'll still be able to see it. So I hope that this will be a more reliable bell curve here. I think this is a lot of light pollution, and maybe it's almost bad to have a bright star like Aldebaran in the picture. See how it does here. This rig that we have is on a pier that can raise up, and maybe you can see down there at the base, it's a height adjustable pier, And as it raises up and down, it retains its ability to be fixed on the North Star. You know, in other words, its ability to be able to be aligned with the Earth's pole, and that alignment, polar alignment, is always sound. And so at night, when I get done, I say at night, when we're done observing, I lower it and then turn it sort of parallel with the roof, and then roll the rooftop back on the observatory and close it up. So you never have to actually take the scope down, and that really is super helpful, because you don't have to align and stand out there and be all cold. You can see that we're on an equatorial mount. This is an iOptron CEM70G mount. So let's see how this... Tell you what I'm going to do. I'm going to go to a part of the sky that doesn't have a bright star in it. And I wonder if that's going to give us almost a better autofocus routine. Then down at the bottom of the rig, we've got this rack that holds things like the power distribution on the left, the that's 110 on the far left, and then the second, what do you call those spaces? I forget. And inside of a rack-mounted thing, a U something or other, I forget what they're called, but in the second space, the upper box is a power transformer to transform the 110 down to 12 volt. And then the little box that's beneath that is a power distribution box for that 12 volt electricity. And that power distribution box sends the power to different objects that we have, like the focuser and the camera on the front of the scope and the camera that's on top of the scope. We run actual 12 volt power to each of those. And then the next object inside this rig rack that's here at the base of the scope is the little box that allows us to send the images from the telescope into where I'm sitting, which is about 200 feet from where the telescope is located. And I'm in a nice warm little office, and what that box does, it's the third rack space. It's got two little green lights on the front of it. That box, it receives the data and converts it to fiber optic cable, to messages that can travel over fiber optic cable. And it sends it over about 200 feet of fiber optic cable inside my office. I've got this nice little heater at my feet, and it's just as warm as toast here in my office. On top of that box, there's a USB hub and another switch that gives us internet out at the observatory. So we have Wi-Fi now at the observatory through that little outrigger rig rack that's there. So it's kind of fun to look at all that stuff. And you know what? I think now our autofocus is doing much better. So I think we're going to have, here in just a second when it finishes. Okay, so it's wrapped up. I hope that's better. We're going to disconnect the camera and come back to the screen, disconnect the camera and the focuser. Disconnect the focuser, close Nina, and come back here to Sharp Cap and turn the camera back on and hope against hope that we came up with, oh bummer, oh there we go, it just had to take a new image. Yeah, I like it better, they're not ovals now. So let's begin live stacking here and set this on 20 seconds and 100 gain. So we're on the planet Uranus here, and oh wait, we're not. We went to a place where we could focus, didn't we? Sorry. Let's go back here to our planetarium software and look for Uranus again. Getting kind of close to the city of Louisville, closer to the horizon. It's what are we? Altitude is 18 degrees. I think we should still be okay. Yeah, there's Uranus. So let's back off now and do a plate solve and just bring it back to the middle. The outside temperatures here are 26 degrees. Lionel Richie says, bless modern heating. For sure that's true. I'm going to reset this display histogram. And so this is the planet Uranus that we're going to look at. Wasn't off very far, actually. Okay, now let's start our live stack again. So that's the last image from the these are 20-second exposures. Okay, so there's Uranus right in the middle. We'll do a color balance. And then bring our blacks up. Maybe right about there. And then bring our mids up. Boy, we didn't gain much on our focusing, did we? Just connect our focus here and go maybe 30 in. Just a little haywire tonight on the autofocus. These mids, the mid levels down here will help us pick up those moons. Set our gain here for a second and break my rule here and see if we can tighten up this focus visually. I always say we focus with that autofocus, but it wasn't working very well tonight, was it? Okay, so see how those are farther out of focus. So let's go back in the other direction now. So this is a remote focuser, and what I'm doing is I'm just making it travel about 100 steps at a time, which is too much, but it's the coarse focusing at least that'll hopefully get us in the ballpark. And basically what we're doing now is what the autofocus was doing, but it wasn't doing very well at it. This is amazing, isn't it, that we can do this from like inside a building and see what the telescope is seeing out there. Look at the imaging around Uranus there. Almost looks like you can see a, that almost look like a, in the refraction there, diffraction, almost look like a fake ring structure since it's out of focus, huh? You can see why I don't enjoy doing this visually. It's just too hard. You can travel all over and not know for sure if we're getting closer or farther away. I think we're definitely farther away now, aren't we? Or are we? Columbia, the comet is not visible from the place I live in, so thank you for this. No problem. Well, we kind of got off track here because we went over to Uranus to compare it, and our focus had come out a little bit in the changing temperatures, and we used our autofocus, and it didn't really serve us very well tonight. In Nina, so that's 29,000. That's got to be way. Let's go back up to 30,000 and start there again. Not much better, my goodness. One more time, we're going to go to Nina. And hopefully this will just be a first time run, and it'll work great this time. Let's hope. We're in that horizon level though, aren't we? The focuser, so those connected okay. Gotta disconnect it from here though. Camera off there. Camera on in focuser disconnected in sharp cap. Look at those donuts, man. Then in Nina, focuser connected. Now it's connected. Now let's go to the imaging and start autofocus. And hopefully this will find some rhyme in this reason. Renato, lo siento que la cometa no está, que no se puede verla allá en Colombia. Sorry you can't see it from there in Colombia, but we're glad you tuned in here. No, we're not getting image data here. Well, I'm ready to scrap the idea of comparing with Uranus. Because it is not cooperating with the program over there by that horizon. let's go back to near the comet. And let's just pick an area of the sky that has pretty star-rich spot. Let's go right here and slew to that object. And let's try this focus again and then just go back to the comet. Jaja, gracias por el español. Bueno, Jorge, muy amable. Tengo que aprender mucho todavía, pero muy amable. Ok, aquí está nuestro, there's the telescope. Let's go back to Nina again and connect our camera. Connect the focuser. Whoop. Okay, so those are both connected now. And let's start this again, and hopefully we'll get a lot better focus than what we were getting. Nina is here, imaging. Can't talk to the camera because it was on in sharp gap. So go back here, get the camera again. There's the camera. Okay, now we're getting images from the autofocus, and the trip to Uranus was a bit of a detour, wasn't it? Okay. So now what's happening? If you weren't tuned in a while ago, we have around 67 on now. We're trying to collect autofocus information so we can focus the camera. I'm going to disconnect it one more time and then reconnect it to make sure it's connecting. Yeah, that succeeded. And then let's do the same with the focuser just to make sure. Let's disconnect it and reconnect it. Okay, so the focuser's connected now. Now let's start this again and let it run. And then we'll head back to Comet 2022 2022 E3 ZTF. And we have about 61. If you haven't told us where you're imaging from, where you're observing from tonight with us, please do. And I wanted to call your attention to one other thing. While this is doing the autofocus run, several from our channel had been asking where they could get a hoodie that somehow had something to do with Emerald Hill skies. And they were asking that, and I'm not making this up. So what we did is we went to a store that was able to give us some Emerald Hill Skies merchandise, and we connected it to our channel. So you're able to order it, and you can get things with Emerald Hill Skies merchandise. And you can even click here, it says from Spreadshop, and you can actually go over to Spreadshop and view even more stock here. So you could do mugs and bags and backpacks, you can do hoodies, and you can pick out your color and pick out whatever design you want. Get black or whatever with the white logo. You can get it on your chest or on the upper chest or on full chest. And a portion of the purchase that you make comes to Emerald Hill Skies. And what we do with it, whatever the money is, we don't take any of it personally. We write out a check to a charity that takes care of a different project each month. And one month we'll do Ukrainian folks who don't have a place to live because their house is blown up in the war. And then the next month we'll do Afghan refugees. So how do you get to this? Well, if you go to the Emerald Hill Skies YouTube channel where you are and click over to this thing called Store, you can see the merchandise there. Or you can also go and click on, from there you can click on the little link that says From Spreadshop, and you can see a lot more stock than what we're able to list here on the channel. So I would encourage you to do that. Also, if you haven't subscribed, it would be great if you subscribe. If you're watching this after the fact, you can still subscribe. We do live streams like this once a week or so. We'll come back tomorrow night, 9 to 11 p.m. And let's go over and see how we did. Not ideal. What in the world is happening to our autofocus so we're not? Why are we not collecting this? The camera's connected well. And we always autofocus, and it takes literally 45 seconds to do this before we start the stream. There's a story. Yes, GoWave. Yeah, you remember we talked about that. Kevin from Los Angeles, good to have you aboard. I wonder if the reason that it's failing to detect a difference in focus is because we got so far out of whack, maybe, with our trying to do it manually. And maybe we are so out of whack that it's trying to find some movement, and so far it can't because it is so far off. I think that's what's happening. And I think it's giving up here. So let's go, let's do this. Let's go back to Sharp Cap and get closer visually. And go back here and try to attach that camera again here in Sharp Cap. And look at those donuts. No wonder, right? Wow. Let's go to 2 seconds of 400 and let's connect our focus there. And see, I don't even know where to begin because I never pay attention to this. We'll just start going in and see if these donuts get smaller. So this is the way you have to focus when you're focusing visually. And we get an exposure every 3 seconds. So here I'm going to take another step. And did the donut get smaller? It did. So now we know we're headed in the right direction, at least. And every time we take a 3 second exposure, these will keep getting smaller, I hope, until they don't. And what we're trying to do is get visually closer here, and that'll put our autofocus routine in a ballpark so that it can at least, oh, see they got bigger? So now we'll go back out. There we go. And let's go out, fine-tuning, just to see how close we can get fine-tuning wise, that's actually not bad. That's at 139%. So that's really pretty good. So I don't know if we want to go back one more time to Nina just because we can and try that routine one more time now with being in a stage of better focus. There's the focuser connected, and at least it's because it's connected in sharp cap. Rats. I forgot to disconnect it. Can you disconnect the focuser from up here somewhere? Do you guys know? Focus assistant. No. So the only way I know how to do it is to disconnect the camera here first, so you can go to sharp cap, attach the camera. You have to disconnect the focuser from sharp cap because it won't release it unless you disconnect it first. Now back to Nina, connect the camera, connect the focuser, victory. Go to imaging and try autofocusing now. Whew. All right, so this comet, 50,000 year orbit, I guess, from what we can tell. And it might not even be a regular orbit. It might be, of course, how will we ever know it? Because none of us will be here in 50,000 years, right? But there is no danger for the Earth, of course, because it's so far away from us, about 26 million miles. But I guess the fun part is we're able to see it and observe it without being scared. Now, if you've seen the movie Don't Look Up, you know, in this case, you know, the movie doesn't really hold true, because in this case, do look up and try to find it with binoculars. Once again, if you didn't see a while ago, the place to go is the Big Dipper. Follow the bull stars down to the North Celestial Pole, and then follow the handle until you get about halfway between the North Pole and Capella, and then you got to veer off to the right here a little bit. Let's see how our autofocus is going. Not bad. Had a little bit of a blip here, didn't we? We'll see how this run goes. So anyway, once you find it in this location, then right here, hopefully, maybe you could download a little app for your phone. How about that? Some kind of a little astronomy app, and there are dozens that you can use. Among them are like Sky Safari Pro. You could use Stellarium. Let's have you guys who are listening, about 65 of us on the live stream, if you have a favorite app that you use, tell us what that favorite app is. I use Sky Safari Pro and Stellarium on my phone, but you might have a better app that you prefer. So what we're doing is we're wrapping up the end of an autofocus routine here in Nina. And a couple of little variations along the way, but you can see we're getting a decent parabola. So now we're going to go back to equipment and disconnect the focuser, go back to camera, disconnect the camera, leave Nina, and now we're gonna Go back to the comet live. Salute of the object. This is what the telescope looks like in the observatory. That's a real-time view. And then now that we're here on the object, we'll run over to SharpCap, connect the camera. Do a plate solve, and right there it is down at the bottom. So we'll plate solve here, and that'll pull it up into the center of the screen for us. Plate solving, if you just tuned in, plate solving is where you're comparing the images you're catching in the camera with the images you have on file in your software. And through this magic, almost ninja magic of plate solving, the software decides the telescope is a little bit off, and as you can see, it realigns it so that the comet's right in the middle of the picture. And once this image settles, sure enough, there's the comet just spot on. You can put these a little crosshair here, so you can see how it did a pretty good job getting it right in the middle. And zooming in now, you might be wondering, well, where's the tail? Well, tonight a lot of the tail is lost in moonlight, but what we're going to do is change to live stacking. Comet 2022 E3 ZTF. Put the name of it up there. We're going to start live stacking, and we're going to take 20-second images at a gain of 100, and there's our first image popping in there. We'll align those color bars, move the dark level over here, and maybe somewhere around there. So you see the halo, kind of, the glow around the comet. Then we'll move the mids up, and look how much it moves between 20-second exposures. Look at how much it's moving, just moves so quickly. $128,000 miles a second. Just so you know, very few things in the night sky, except for satellites and airplanes, maybe a meteor now and then, move this quickly. But this thing, of course, I'm at 185% of our frame, of our APS-C frame. The office where I'm sitting, Renato, se queda a 200, ¿cómo se llama? Feet. Pedidas? 200 feet del observatorio. So we're 200 feet from the observatory, where I'm sitting now. And the observatory, of course, is out there. That's where you see the scope. And that's a live view of the scope inside the observatory. That's actually live. And here's what the scope is seeing. And we were observing earlier in the evening, look at this little artifact that's left over when we live stack. It's like the core of the comet, because it vanishes from that last location. The core of the comet is no longer visible there, but there's a little bit of a brighter halo where all the material is, you know, being burned off, sublimating off. The chemistry of the ultraviolet radiation just lighting up the chemistry inside of that comet, the ice and the different gases that are being sort of lit up as they're burned off and as they're cast off. So our theory is that all those gases are glowing, but the core is moving. And what we're seeing here is kind of a leftover part of that glow that was there 20 seconds ago, and it's just the cast off stuff that's still glowing there. And I find this extremely interesting that our live stacked image, these 20-second exposures, so now we have 3 minutes of exposures, that it leaves this dark artifact where the core was before, but it lets us see an outline of the brighter sublimation and things that are being burned off as the comet streaks across 128,000 miles per hour. 128,000 miles per hour. Pies. 200 pies, entonces. Gracias, Renato. Well, if you have any questions about the comet, if I can't find the answer, then I bet somebody on the live stream will know it. We have several astronomers have a lot longer experience than I do here. We have about 82 people that are on the live stream. And if you just tuned in, we're using a technique called live stacking. And what that's enabling us to do is capture all this green glow around the comet. And we would be able to see the comet core. But this greenish glow around the comet is so faint that in the moonlight, we would have lost it. The moon is at about 94% tonight. And if you stop and think, the moon kind of makes a background glow. And I'm trying to think of how we could compare this. Let's compare it to riding on a jet. If you've ever ridden on an airplane, you've got that background noise of the motors running, the jet motors running. And it makes this roar the whole time you're sitting on the jet. Well, the moon is at 94% tonight. And you can see here in Stellarium, the moon is right here. And it is incredibly bright. So much so that at this angular distance, where's the little angle measurement here, which is exactly 38 degrees. At this 38-degree angular distance, we're picking up the background noise of the moonlight that's just casting a glow around the night sky. And if you don't believe it, just look at the glow in the observatory. There is so much moon glow that's happening that it makes a background glow that's kind of like those jet motors. But when you put on your earmuffs and actuate your, what's it called, noise attenuating earphones, if you've ever had those before, and turn it on, the earmuffs just go quiet. And now you're sitting inside this absolute still, quiet space. Because why? Because the earphones have compensated for that background noise by getting rid of it with sound waves that are the other direction. And also because there is some attenuation because the things are over your ears. The muffs themselves attenuated some. Well, the live stacking process sees the background glow of the moon, and it knows that it's not normal because the background glow of the moon kind of sort of twinkles a little bit. It changes, and every single slide, every single picture that we capture, it says, wait a minute, that's not normal, and it reduces all those background glow like light pollution and even a little bit of the moonlight, and it makes that darker, which lets us darken the sky but keep the glow. However, it's not foolproof, and at just 7 minutes of live stacking, it's not perfect either. So we don't have all of the background glow of the moon tuned out. But we have enough that we can spot the greenish glow around the comet itself. And that, to me, is kind of fascinating. And you might say, well, why is it long? Well, that's because this is how far it traveled in 7 minutes. Now let me back off to 100% of our RASA's view through this ZWO ASI2600MC Pro camera. That's 100%. Now this is at full frame, APS-C. So that is the real comet glow that you're seeing there. That's not fake. It's just that it's stacked for 8 minutes. Now if you look at it through binoculars tonight, you wouldn't see that smudge of green because your eyes can't live stack. Your eyes only see one real frame at a time. And I've done some reading on this, and it's kind of like your eyes are seeing what, about a 30th or a 25th of a second. So your eyes don't have the ability to save more than a 25th or 1/30th of a second of an image on the optical nerve. Maybe it might be 1/25th or 1/30th of a second, but then it's on to the next image because your eyes see real time. But with this approach that we're using, which is 20 seconds of exposure of the comet, and then save that image and take another 20-second image and then lay it on top, and then save that image and another 20-second and lay it on top, and then average those. We're not really combining them. If we combine them, then there are a number of reasons we can't combine them properly, but what we do in live stacking is we average the light sources. And what SharpCap is doing, this is the software we're using here to live stack, SharpCap is saying, I don't really understand what's happening in the middle of your frame, but I'm going to show you what I'm seeing. Now, meanwhile, the telescope is traveling with the stars because the telescope is moving at precisely enough to compensate for the Earth's rotation. So as the Earth rotates and the stars appear to move across our sky from horizon to horizon, from east to west, the telescope's compensating for that part. But the telescope is looking at this and saying, I don't even know what that thing in the middle is. So what it does is it's freezing the stars. Each star is a pinpoint of light. But it can't freeze the comet because the comet is moving across the field of stars so fast in our foreground. The stars are like, anywhere from, zillions of light years away. Let's go over to Stellarium a second and let's just look at a couple of stars in this area and see if there are any distances here. That one's 433 light years. This one is 651 light years. This star is 959 light years. And by contrast, this comet was last night. I wonder if Stellarium can tell us the distance of the comet real time. It is. It's 43,000 kilometers. Is that right? 43 mega kilometers. Would that be 1,000 kilometers? So it's 1/4 the distance between here and the sun away. Last night, it was 26 million miles. So that can't be right on kilometers, huh? I'm not familiar with that way to measure kilometers. Are you? Where you put an M, you put an M in front of it. Oh, here we go. Now I did it correctly. Oh no, that's the coma diameter. The coma is 298,000 kilometers wide. And the tail is 1.5 degrees, and we're not seeing the tail tonight. The core is only 10 kilometers wide. So the rock, or the icy snowball in the middle, is only 10 kilometers wide. It takes light 2.5 minutes to get here from the comet. And distance-wise, it's 43 kilometers. So that must be million, right? 43 million kilometers. Yeah, that's what that would have to be. Back here, again, you can see the trail that it's leaving as it live stacks across the sky. Now I wonder if, as we zoom in on it, can we make out any, can we make it so it shows us any of the tail? Let's see, 5:30 a.m. in UK, 100% clouds, but you've got your 80 millimeter refractor at an ASI 533 camera, hoping for a gap in the clouds, but not looking good. Renato, kind of like noise cancel. That's what I was looking for. Renato, that was the exact phrase I was trying to say when I said attenuate. Noise canceling headphones, right. It is complex technology, you're right. It's all done in the software. Yeah, million is right, Stu, thank you. So let's see, this is 80%. Let's go in until we're at 100% of the RASA's closest Now let's see if we can make it show any of that tail in the moonlight. Let's darken the sky a little more, and then let's brighten it with our mids, and see if we can make the tail any bigger or brighter. Let's try bringing our white levels all the way in here until we start seeing information. There's no sense in having it out there. Bring our mids up a little more. We've been exposing for 15 minutes now. Ah, there. I wonder if that's a little bit of the tail right here. Just a little bit in the moonlight. Boy, there's so much moonlight. You can make it out, but it's just, I'm going to hold the shift key down and use that on this black level until we've masked the sky just enough so that I can show you, look at this pattern here. See how this part is darker out here? And this part is darker here? But I'll look at this pattern here. That's where the tail is starting to show up. Now I turned off my flats a while ago because I wondered if that would give us, oh no, they're back on now. I wonder if that's the right flat. It's January 12th, it is. And I wonder if that's the right dark. No, this is the dark we needed. But that shouldn't matter. Now let's bring our mids up a little more now. Look at that. Boy, sure can't see it racing across the sky. We're about 100. We're about 100 on the live stream right now. I'm going to clear this live stack now and go back to live images and just show us what we can see if we snap a picture, let's say every 7 seconds at an ASA of 400. This would be like if you are familiar with 35 millimeter photography, maybe you've got a DSLR or something. Imagine setting the camera frame on 7 seconds. 7 seconds. And imagine if you put the ISO on 400. That's kind of what this would be mimicking. First of all, you got a lot of moonlight there. We'll go back to our view in the observatory. There is no light on the observatory, in the observatory. Over there on the wall, there is a tiny, 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 tiny little wheat lamp orange LED, and it's so dim that you can barely see it. But look at the moonlight flooding that observatory. That's how bright the moon is tonight. And that's what we're seeing here. This is the moonlight. And unfortunately, there is no filter that will mask the moonlight, because the same light that makes the moon glow and reflect is the very same wavelength that's reflecting off the comet. So you can't filter the moonlight out. Stu says the comet nucleus was estimated to be about 1 kilometer, and it rotates every 8.7 hours. That's cool. Now look, every once in a while you can see a little projection when the atmosphere is exactly right. A little projection perhaps. So I don't know if we can make this any better by going to like 5 seconds. Maybe the sky will be a little bit darker. Will we see any more of the tail though? So that's a 5-second image. I don't think we're going to be able to see it. Let's go to 3 seconds. I think it'll just get darker, and I don't know that we're going to make out any more of the tail. It's at 400 gain. Let's try going 5 seconds and decrease our gain, which will decrease the noise a little bit. So now these are 5-second exposures, and down here in the lower right, you can barely make out perhaps a bar graph, and that bar graph shows you every time that a new image punches in. So with the moon glow tonight, we are not getting the tail. You know what else? We do have Bortle 6, Bortle 5 maybe, Bortle 5 skies here in Louisville. And what that means is a lot of light pollution. Jeremy, that's what we were just talking about. We don't think the tail has disappeared. We just think the tail is faint. Let's face it. The tail is faint. And with the moon being at 94%, and we are on the outskirts of Louisville, Kentucky, too much light pollution to be able to see it. By the way, if you like content like this, we would love to invite you to subscribe and click that thumbs up, because what that does is it sort of elevates the channel and gets it up in everybody's, heads up windshield, so to speak. We do these live streams usually once a week. We'll be on again tomorrow night from 9 p.m. to 11 p.m., but tomorrow night the moon will be at 98%. So it won't be any better for catching the tail. So why don't we go back to live streaming, to live stacking now, and let's go back to, well, let's try one more thing first. Let's go to 15 seconds and drop this to 200 just to see if that helps us any. And here's our first image. There's no live stacking going on here. This is just a pure 15-second image. No tail whatsoever. Let's go to 20 seconds. And let's let that. So we'll be on tomorrow night, 9 p.m. to 11 p.m. Eastern Time. Mike, hello from Georgia. Good to have you here, Mike. Mike is one of the guys that helps us at the Patreon site. And if you go to Patreon, what is it, Mike, / Emerald Hill Skies, is it? Patreon / Emerald Hill Skies, I think it is. Is that what it is? Yeah, Patreon / Emerald Hill Skies. Mike has basically made a sort of a patronage pledge just to kind of pitch in and help so that people around the world can be helped. And I mentioned a while ago, whatever comes in, we send it back out to charity. We don't take any of it. We don't buy cameras with it. We don't buy observatories with it. That stuff is purchased and it's out there. But to support the channel, these guys pitch in at patreon.com / Emerald Hill Skies. And I could put that on the screen. Let's see. If I go to the scope cam, for example, and go to the title, I could put it there, right? And then that way when I come back here, it would be there. Well, anyway, that got rid of the comment, didn't it? But anyway, that's the site, patreon.com / Emerald Hill Skies, if you'd like to do that. And now let's go back and put the title back, which is C 2022 E3 ZTF is the comet. So go back to the screen view now, and let's try leaving it 200 and start live stacking and see what 20 seconds at 200 does, just out of curiosity. Jeremy says, I'm subscribed to your channel and glad you caught it live. Thank you, Jeremy, for being here. Jeremy says, Neowise was faint. I was just able to make out the tail. I can't imagine how much more difficult this is. Yeah, you're right. In city lights especially, if you could get out into the, the edge of the city, it might be easier. Okay, so we're going to do some tuning here now of our histogram. Let's go ahead and pull these white levels all the way over because that's not helping us that much. Let's tune the color balance and bring the darks up to right here. Something like that. That's actually going to be interesting if we use the 20 seconds at a gain of 200 tonight instead of 100. I'm curious as to what that'll allow us to see here in a second after it live stacks for a while. That's just 80 seconds, and look how much it's already moving. Stu says, I thought they were coffee donations. Well, some people pitched in and called it for coffee, but we don't use it for coffee. We don't drink coffee here at Emerald Hill Skies. But here's a check so that you know, for example, whatever comes in, we send it back out exactly what it is. We don't keep anything on our own. This check went to Afghans who were over there in Kabul. These are the Afghans that they weren't able to evacuate. And a lot of them are living in blue tents, and they have no way to farm. They have no jobs and no way to eat. So we're investing this to help them stay alive rather than buying coffee or equipment with it. So if you were to go right now and click that little, what's it called? There's something beside the channel. I forget what it's called, Super Chat or something. And if you did a $3 Super Chat right now, all of the money that Google / YouTube shares with us, it all goes to help people who are in need, and we don't take any of it. Likewise, if you click on that store and go to the merchandise and buy something like a hoodie or whatever, that all goes to help people who are in need as well. Azray, good to have you. You're in Arizona. What are your skies like? Do you have some clear skies, or are they cloudy out your way? We were just wondering if, using this approach, we might be able to see more of the tail. We're just seeing the glow around the comet. To put it in perspective, here's the way the sky looks overall. So all that star point light, and then you get this the beginning of a tail here, I think. And then we get these artifacts where C2022 E3 ZTF moves, traveling at 100, whatever it was, what was it? 128,000 miles per hour. I have to remember that. 128,000 miles an hour, and at a distance of just a mere 26 million miles, it leaves the dust behind it to glow. But the core has moved out of the way, and that's this artifact that we're starting to see here in the live stack process. Now there is a tool, and I don't know, oh my goodness, look what Stu did. He pitched in $3 and he said, coffee for Afghans. Stu, thank you. Thank you very much to help them. I really thank you on their behalf. I hate Clavin Lim. I love your content. Any tips for EAA with a mirrorless DSLR? A mirrorless DSLR, well, you would need a tracking mount, first of all. If you took an exposure that was anything past, you know what? What's the longest exposure you can take before you get star trails? Can you get 2 minutes with a 135 millimeter lens, and they're already showing, right? You would need some kind of tracking mount, I would think. Azray says it was clear for a little while, did some live stacking with a 16-inch Dob on Orion. That's cool. Jeremy, if the comet did in fact lose its tail, would another one form? Well, the tail is merely the sublimation of lots of ionized particles that are traveling away from the direction of the sun. And the tail has nothing to do with the movement of the comet, actually. It has to do with the power of the rays of the sun that are ionizing those particles, and with this magic of the combination of the ionization and also the power of the solar wind pushing literally against that light and that ice and that chemistry, that's what makes a tail. So I don't think it's actually going to lose its tail as long as it's this close to the sun. But the tail will become visible and invisible based on light pollution that you might have near your location and moonlight. And we're at a peak of moonlight now, 94% tonight, 100% tomorrow. That's what's causing it to lose its tail. Hey, we do have a participant, I can't pronounce the name, who just went out and saw it. So well done. Good job. Okay. Let's see what we can do here. We're going to make the sky a little bit darker. Stu says the comet was hit by a CME. Is that like a solar prominence kind of thing? And it appeared to lose its tail for a while. So I guess that would be a phenomenon of the sun which projected out that prominence, or what does a CME stand for? It's a new term for me. Definition of CME astronomy. Coronal mass ejection. Wow. So it was a large expulsion of plasma and magnetic field from the sun's corona. So when that coronal mass ejection traveled out from the sun, it blew away the tail for a while. I suppose that is a way that you're right, Stu. That way it would lose its tail. But the particles come right back as soon as that ejection is out of the way, because the sun is now illuminating them just like a neon light again. Coronal mass ejection. Let's remember that, everybody. Coronal mass ejection, okay? Let's do some more fine-tuning here, just in case we can improve on this. You know, it almost looks like that this part here is traveling during the 20 seconds. And then an exposure starts again. And in between exposures, this dark area is the part that's being left behind because the core is traveling. That 1 kilometer wide core. So like a solar flare, huh, Stu? Super, super fascinating, gang. Well, I tell you what, why don't we kind of take a picture of this and kind of remember it in our minds? I think with the moonlight, look at that glow around it, and indeed the glow does seem to be traveling in an upward direction up this way, because it's darker down here, see? So if you can kind of think about that as the little beginning of a tail, you know what? We might be seeing the start of a tail here at 9 minutes 40 seconds. We might very well be seeing the beginning of a tail. Jeremy says, this is one of the most interesting comets that I've seen since Hale-Bopp. Jeremy, are you saying that because it's green, for example? Because it's definitely got a greenish tinge. Trying to adjust the colors here. I'm the last person in the world you want doing this because I'm kind of color deficient. Jeremy says, absolutely. Yeah, I understand that greenish tinge comes from a chemical inside the core that's being, you know, baked out of the comet, and the sun is hitting that chemical. Let's verify that. Green Comet, why is it green? Comets get their colors by reflecting different hues of light based on their orbital positions and chemical compositions. C 2022 E3 ZTF appears green because the sunlight is interacting with carbon and cyanogen in the comet. Carbon and cyanogen, and that's what makes it appear green. Well, remember, these are live views, not, you know, famous 2-hour views, astrophotography style. This is live views of live stacking, and I think we're going to go ahead and call it a night, you know. But thank you for being with us. We still have 80 on the stream. I hate to leave. Stu says I saw McNaught in 2007. It was fantastic, but seems we don't see as many comets in the southern hemisphere. I wonder if there's a reason for that, Stu. Maybe has to do with the fact that the comets, maybe comets generally travel with the revolving direction of the Earth. So maybe when they come in at us, the North Pole maybe is, let's say, facing them. But it seems like when they leave, at some point they should be visible. So let's Google that as well, Stu. Does northern hemisphere why am I not? Does northern hemisphere see more comets than southern? I don't know. Doesn't seem to be a predominance of titles that are talking about that. Rascal77, I thought it was green with envy of Halley's. Shows what I know. Rascal, that's a really good theory. Azray, thank you for taking part. One last view of the comet and then we'll close out. Thank you for taking part in this. Don't forget to subscribe if you like content like this. We'll be back tomorrow night, 9 p.m. to 11 p.m. Eastern. We'll see what we can pick out in the moonlight. If we see enough of the comet, we'll go and start working on the Herschel 400, which that's our normal fare. We typically go through Herschel 400. We're looking at the secret deep. We're observing the hidden treasures. And also we've been looking at the Caldwell objects. These are all books by Stephen James O'Meara, and one of the greatest visual astronomers of our time. And we're working our way through all those lists kind of simultaneously as we get the right skies. And so I'd encourage you to come back. If we stop looking at the comet tomorrow night, we could start back into those, and I hope you'll join us. Go ahead and subscribe if you would. Stu, thanks for the encouragement. Thanks to all of you, and we'll look forward to seeing you again. Take one last glance at the live stacked view of Comet C 2022 E3 ZTF. Good night from Emerald Hill Skies. Thanks to God for making images like this that we could, amazing objects like this that we could see in our night sky, and we hope you have a good night's sleep, or if you're getting up, a good day wherever you are in the world. God bless. Good night.